RISACalc is a web-based application for individual component design, which provides engineers with an easy-to-use interface that allows for full control over inputs such as geometry and loading, in addition to graphical and numerical results, including robust, detailed reports. In this video, we'll take a look at the wood member design functionality in RISACalc. So here I already have a beam created, and I'm going to go ahead and look at properties, and we can set the wood properties of this particular member. So we'll choose either solid sawn or engineered wood. In this case, I'll choose some solid sawn. I can go ahead and set my species and my grade. Let's make this number 1 lumber. I can go ahead and set the shape type then. So I'm going to make this 2x12, and then I can set the number of plies as well. I can also see the properties that are being calculated for the material and the geometric properties as well. Before we leave properties, I can also go ahead and click on the gear here to see the codes available. So we can see the different NDS codes as well as the CSA Canadian codes. Next, I'm going to go ahead to span. I'm going to add a back span here. So let's add it 3 feet, and I'm going to make it a cantilever. So no condition, no support condition at the end here. Next, I can go ahead and say my design conditions. I can say that I want to brace this for, I don't know, add a plane at the supports and at the top of the member as well at the supports. I could also change some other criteria, or I can go ahead to start adding loads. And so I'm going to go ahead and first add a point load. So let's say 250 pound point load in the dead load condition at 5 feet. And then I can also add a distributed load. So let's say 100 pounds a linear foot, and let's make that live load along the entire member here, along all 13 feet. And so while that's being done, we can see that the load combinations are automatically being created for us. We could go ahead and edit the load combinations and how they're created, but in this case, we'll leave them the same. And then I can go ahead and click the check mark to toggle on the unity check. So this is just going to run the calculation and give me my results. And so now when I go ahead and look at my results, I can see my unity check. Now I'm a bit overstressed here, so if I wanted to make a change, maybe I wanted to reduce my load, I can go ahead and click on the load here and say, let's make that to 150 pounds rather than 250 pounds, and I can toggle back on my unity check. And hopefully now we get a passing unity check, in this case that we do. We can also go ahead, I'm going to minimize the detailed report, and I can go ahead and turn on some of my diagrams. So I can show a shear diagram, a moment diagram, our deflections, and our reactions. Now, if I go ahead and bring that report back up, we can start to look at some of the same information, so like diagrams, or we can more importantly go ahead and look at the calculations. And so I can see that the controlling limit state in this case is a bending and axial compression analysis, so I can expand that. And I can see all the code references and all the information filled in, all the equations filled in for exactly how that calculation is coming to that unity check. And when I'm ready, I can go ahead and download a PDF. Let's go ahead and move on. I'm going to go ahead and add in a wood column now. So I'm just going to click plus to add in a wood column, and let's make this a wood member again. And we'll say it's solid sawn. Let's make it, I don't know, maybe a 6x6. So we'll choose a 6x6 post. And we'll leave all the material the same. I'm going to go to my span condition, and I'm just going to make this a fixed condition at the bottom, and at the top we'll make this a cantilever, so just a cantilever little post here. I can look to add my design conditions. I'm going to keep those all the same, and then just add a few loads here. So let's add a point load at the top here in the downward direction. So let's call this a dead load, and let's say the magnitude is going to be, I don't know, 1 kip is fine. And then a distributed load, maybe we add a wind load in this case, so I'll choose my wind load category. And we're going to go ahead and add 150 pounds a linear foot, and we can add up to 250 pounds a linear foot. So we can add this trapezoidal load. Again, the load combinations are being created in this case, and I can go ahead and toggle on my unity check. And so when my unity check goes through, in this case, again, we're getting a failure here. We can go ahead and reduce our loads, or maybe we needed to change the size of our member here. So maybe I needed to go up to a much larger member in this case. So let's go up to maybe a 10x10, for instance, and go ahead and rerun the unity check on this particular member. And we now get a passing grade. And so now again, I can go ahead and look at all of my diagrams. So we can see here I've got different reactions, the deflections, our moment diagram, and our shear diagram that we can turn on. Let's go ahead and turn off the loads so we can see those a little bit better. And we can also see the deflection here. So we can see how that freestanding element is deflecting. Now, if I go ahead and look at the detailed reports, again, I can go ahead and expand different sections of this. So the properties, the diagrams, and the load combinations created, as well as the calculations. And so we can go ahead and look again at that bending and axial compression. And now when we're ready, we can go ahead and click the download button. And we're going to generate a PDF in this case that we can go ahead and open up in Bluebeam and then send to other engineers or owners or other code officials as we need. So I can go ahead and open up this project and see the output here in this PDF. Thank you for watching this video on wood member design in RISACalc. For more information about RISA and RISACalc, visit risa.com.